Okay, so what is a quadratic equation? It's any equation that can be written in the form ax squared plus bx plus c is equal to 0. How does this differ from a linear equation? The square, right? Linear equation has no square. Okay, very good. So the standard form is you want the polynomial in descending order. What does that mean? The squared term goes first, the x term goes next, and the constant term goes last. That's called descending order. And you want one side equal to 0. So we tend to like to put in standard form because that's one way we can solve these quadratic equations. Can I point out a mistake that sometimes happens? Okay, what if I add 5 to both sides? What if I divide by 11? Have I solved for x? I got x by itself. Why have I not solved for x? Because there's still x on the other side. Okay, but the method I use is what we've used before, right? So that's what we did for linear equations. So you need to identify first, is it linear or quadratic? Because your approach will be very different. Linear, you do what I did. For quadratic, you make one side 0, right? Very different approach. Okay. Wrong. Not solved for. When one side's 0, what we're going to use is a logic, just basic logic. It's called the zero product principle. If A times B is 0, what conclusion can we make? A is 0, because then A times 7, 0 times 7 is 0, right? Or B is 0, right? 15 times 0 is 0. If one of them is 0, the whole thing's 0. Does that make sense? So it needs to be a one side equals 0. The other side needs to be product only. No addition, no subtraction, product only. Then you can solve it. So let's go ahead and solve this by factoring. Is one side 0? Yes. Is in descending order? Yes. Can you factor this? I hope so. Do you guys like to do the AC method, or you like to do guess and check? AC, guess and check. Okay, do that. Do that method. Okay, so then A times C would be what? 8, all right, AC. And then B is what? -9. Okay, so what are factors of 8 that add to make -9? -1, -8. My apologies. Those multiply to make -8 or +8 and add to make -9. So then we split this up and we say -9x is the same as -8x minus 1x. Could I have split up differently? Yeah, I could have done the opposite order. 4x squared plus 2 is equal to 0. And we can factor by grouping. Personally, I'd probably prefer guess and check. But you guys said AC method, so we're doing it. What's the greatest common factor of the first pair? 4x. So what's 4x squared divided by 4x? X, very good. And what is -8x divided by 4x? -2. All right, what's the greatest common factor between -x and +2? Very good. -1. If the lead term's negative, you better take out a negative. So what is -x divided by -1? +x. What's +2 divided by -1? -2. And if these match exactly, we did things right, and we can factor that out. X minus 2 times 4x minus 1. So what's great about the AC method? Always works, right? But it might take a little bit longer than guess and check if you're good at guess and check. Okay, so now what? I factored one side, said the other side equals 0. What do I do? The product of two things are equal to 0. If either one of them is 0, the whole thing's 0. So I say either x minus 2 is 0 or x minus 1 is 0. In either case, the equation will be true. So I add 2 to both sides. I get x equals 2 is my solution. Add 1 to both sides and say 4x is equal to 1, or divide by 4, x is equal to 1/4. Can we believe these solutions? Yes. Assuming I didn't make a little mistake, these are in fact solutions. I don't have to check them, but I can. So quadratic equations can have two solutions. A little different, right? We never had that for linear equations. How many solutions could we have for a linear equation? One, or all real numbers, or no solution. So right now, we know we can have 2 for quadratics. Can we have 1 for quadratics? All right, let's continue. We'll talk about that as we go along. So yeah, let's solve this one. I'm going to distribute first. And the point is we want to make one side 0. So t squared plus 6t. Let's go ahead and subtract t from both sides. And let's subtract 24 from both sides. The goal being we would very much like one side to be 0. Can we factor this in our heads? Is it factorable? All right, so t and t, what are factors of negative 24 that add to make 5? Positive 8, negative 3, and just always double check. Positive times a negative is negative 24. Positive 8 plus negative 3 is positive 5. All right, so then we say t plus 8 is equal to 0, or t minus 3 is equal to 0. Either t equals negative 8 or t equals 3. We got two solutions again. What does it mean if I plug in one of these numbers in the original equation and I get a false statement? It would mean that I did something wrong. Right? Okay, any questions about this? This one factors into x minus 5 times x minus 5. So x equals 5 is a repeated root. Looks like these can have one solution. All right. The next important concepts. So in math, we often work really hard to discover something's true. Once we realize it's true, then we take a shortcut and don't think about it ever again. This is one of those scenarios. Okay. The common mistake here is, how do I solve x squared is equal to 25? So the common mistake is we tend to take the square root and say x equals 5 is my answer. So why is that wrong? We need to understand it fundamentally so we don't make the mistake in the future. Why is it wrong to say my answer is 5? It also can be negative 5. So when it says solve, we need to find every solution, not just one. What is this mistake that's happening here? Between these two steps, something is going wrong. So what happens when you take a square root? No. It turns out it's always plus. If I want the negative square root, you know what we do? 25. I always want this to be 5 because I want to know what I'm getting. If I want the negative square root, then I do this. And then I know I'm talking about -5. So this is the really key thing we need to memorize. This is always the positive root. So then what's going wrong? It turns out this is not equal to x. It's equal to absolute value x. Why is that? Well, what happens when you square a number? Let's say, what happens when you square -3? +9. If you take the positive root, +3. So I took a -3, made it +3, like absolute value, right? What if I put in +3? +3 squared is 9. We take the positive root, it's 3. So if I plug in 3, I got 3. If I plug in -3, I got +3. So the key thing here is when you take the square root of a perfect square, you get an absolute value. Any questions about that? And we know absolute value equations have two solutions, plus or negative of the other side. Absolute value of 5 or absolute value -5 are both 5. Are there any questions about this? Yes.
Can you repeat what you said when you take the square root from?
If I take the square root of a perfect square of anything, the answer is the absolute value of that anything. Right? Okay. So what are we going to do? Well, I'm going to usually skip this step and go straight to there. X is equal to ±5. Okay, so now we're ready to solve using the square root property. You do this when you have perfect square, and you really only see one variable. I only see one s, I only see one x. If there's an x squared and an x, I can't do this. So let's add 32 to both sides. And then we do what? Take the square root. And I guess I'll write that on the left side, I get the absolute value of s. What's the square root of 32? Not perfect square, right? Are there any perfect square factors of 32? 16 times 2, is that right? So what's the square root of 16? 4 square root 2. S is equal to plus or minus 4 square root 2. Any questions about that? All right, example 5. I see only one x, it's in a perfect square. It means I can use the square root property. Let us subtract 27 from both sides. What should I do next? Divide by 3, good. You should think reverse outside in. So multiplying by 3 is the last thing that's done. So to undo that, we divide both sides by 3. That gives me x minus 9 squared is equal to -9. Okay, what should I do next? Square root both sides. Okay, x minus 9 is equal to, all right, what mistake did I make? Plus or minus, yeah, okay. So this should have an absolute value. This can be thought of as square root of 9 times square root of -1, which is 3i. So x minus 9 is equal to plus or minus 3i. And I'm certainly okay with you skipping straight to this step. Just remember the plus or minus. And our last step would be add 9 to both sides. So one solution is 9 plus 3i. Another solution is 9 minus 3i. Okay, any questions about this? Okay. Next, we want to deal with problems like this, where we can't use the square root property. So for instance, what if I added 6x on both sides and subtracted 7 from both sides? The square root property gives me a total mess, right? Why doesn't the square root property work here? X is on both sides, right? So we can't use the square root property there. But it turns out you can if you use this magical trick called completing the square. So let's go over how we complete the square. First, we need to notice a pattern of perfect squares. This is a perfect square because it's a binomial squared, right? So what if we FOIL it out? What if we do x plus 3 times x plus 3? What do we get? Good. You said x squared plus 6x plus 9. So you definitely want to get to the point where you can do the whole thing in your head. I wrote every step down. Well, I FOILed x times x times 3, 3 times x, and 3 times 3. Right? So what do I want to do? I want to start with these two and come up with this number to then go backwards. Let's do another one so we can see the pattern here. What's x minus 5 times x minus 5? If we FOIL, we get x squared minus 5x plus 25. X squared minus 10x plus 25. So given these two, how can I come up with that 25 number? Does anyone notice the pattern? So with the 6, how can I come up with a 9? With the negative 10, how can I come up with a 25? 6 divided by 2 is 3, and then what? Square it. Negative 10 divided by 2, negative 5, square it. 25. So that's our trick. Are we comfortable with that? Okay, so I'm going to take whatever this number is, and I want to multiply by 1/2, and then I want to square it. That will give me the number I want. Okay, so that's the formula here. If I have x squared plus a number times x, I take half of it and square it. And it will factor into x plus 1/2 that number. Square it. So example 6, it says complete the square on this. Okay, so I take this number and I do what? Divide it by 2 and square it. So that gives me what? Yeah, negative 8 squared is 64. So let's check it. What's x squared minus 16x plus 64? Does it factor into a perfect square? Yes, I take half this number. Take half that number, -8. Is it true that x minus 8 times x minus 8 gives us our trinomial? Good. So are we all comfortable with that? Okay. When does this not work? This will not work if you have a number in front of the x squared. It needs to be 1. Needs to be a 1. Okay, so you can solve any quadratic equation by completing the square. And that's not true for factoring. Not all quadratics are factorable. In fact, most aren't. If you make up random numbers, more than likely, it's not factorable. Okay, so how are we going to solve these? These are the steps. And I said it doesn't work if that leading number is not 1, right? So that means step 2 is very important, that you divide both sides by a. You need to divide both sides by a so that this becomes a 1. And our formula will work. Okay, so we're going to move the constant over, divide by a, and then we will come up with that magic number by completing the square. And then we'll just do the square root property as we've done in the past. So let's go ahead and do that on this problem. So step 1, you want to first do what? Good, move over the constant. So x squared minus 6x is equal to -7. Okay, and I'll leave some room here. And step 2 is skipped because the leading number is 1. So we already have a 1 here. We're going to skip step 2, which would be to divide by that number. So now we need to complete the square. What is that magic number that we need to add to both sides? -6, divide by 2, square it. -3 squared is in fact 9. Okay, so this is an equation, so I can't just add 9 willy-nilly, right? That makes things out of balance. I must add 9 to both sides. All right, any questions about that so far? And then, so what was the whole point of that? Why did I add 9? This came out of nowhere. Does anyone know why I added 9? It's make a perfect square. So I need to factor it. It factors into what squared? And the key is you take half that number. What's half? Very good. -3 and -3. At this point, most mistakes have occurred already. So the most common mistake is skipping step 2 and not dividing both sides to make that 1. The second most common mistake is not remembering to factor or factoring incorrectly. So I always like people to double check this. How can I double check this factor correctly? Multiply it out with x minus 3 times x minus 3. You get a -6x and a constant. Double check that. Okay, after that, why did we factor? What was the whole point of factoring? so that we could take the square root to get x by itself. Remember, when there were multiple x's, we couldn't isolate it. But now we've created a scenario where there's one x that we can isolate by completing the square. Okay, are we comfortable with skipping the step, the absolute value step? Okay, so what should I write on the left-hand side if I'm skipping the absolute value? X minus 3. And on the right side, I should write plus or minus square root 2. And finally, you add 3 to both sides. So after the fact, how many solutions do I have to my original quadratic equation? 2 solutions, very good. Can you tell me if the original one would have been factorable or not factorable? Non-factorable because we have irrational numbers, right? Square root 2 is an irrational number. So no way could we have factored that. Okay, let's try a slightly more difficult example by completing the square. Okay, step 1 is what? So yeah, that is a valid first step. You may divide by 9 first, or you can move the constant over. Which would you prefer? Okay. I kind of prefer dividing by 9 first, but that's not how the steps are written. So I'm just going to do how the steps are written. Okay, so that's step 1, move the constant over. And step 2 is now, this really needs to be a 1. So let's divide by 9. 9x squared minus 6x is equal to negative 2. Okay, so if I divide by 9, it's both entire sides by 9, right? Okay, which I can split up and divide each term by 9. So what is 9x squared divided by 9? X squared, that's what we wanted, right? And then what's negative 6 divided by 9? Good, negative 2/3 x is equal to negative 2/9. Now that I have an x squared and x term, and the leading number in front of x squared is 1, now my completing the square formula works. So step 3, let's go ahead and complete that square. What is that magic number we need to add to both sides? Divide by 2 or multiply by half. If it's a fraction, let's multiply by half. Be a little bit easier to think of, right? Multiply by half and square it. So then these 2's cancel and I get negative 1/3 squared. The good news, this number is always positive, right? Negative times negative is positive. What's 1/3 squared? Yeah, it's 1 squared over 3 squared is 1/9. So let's go ahead and add 1/9 to both sides. All right, what is the next step? Very good, factor. And the shortcut would be what to factor it? Half of this, which we calculated here, right? Half of that we said is negative 1/3. What's negative 2/9 plus 1/9? Negative 1/9. Yep. It's a common denominator, so we can add negative 2 plus 1 is negative 1. And you can double check. How we double check is we say, well, what's negative 1/3 plus negative 1/3? Negative 2/3. It's negative 1/3 times negative 1/3. positive 1/9. Okay. Any questions so far? Yes,
How did you get the 1/2 again?
the 1/2.
Yeah,
What 1/2?
when you multiply with 2/3.
Oh, that's our formula. How you come up with this magical 1/9 number to complete the square is you take half of the coefficient of x. So I took half of that coefficient by multiplying 1/2. And then you have to square it. So that's just memorizing a formula. Any other questions? So why did we complete the square? What's the next step? So we can square root both sides and get x by itself. So we're going to skip the absolute value, right? X minus 1/3 is equal to plus or minus. How do we simplify that square root? All right, I'm going to write this as square root, yeah, times square root -1, which is I, right? And this I can write as, I'll just write another more step. Square root of 1 over square root of 9, I, which is 1/3 I. And finally, we add 1/3 to both sides. 1/3 plus or minus 1/3 I. Okay, so those are our two solutions. Two complex solutions. Any questions about that? Okay, so 1/3 plus 1/3 I and 1/3 minus 1/3 I. All right. So the next thing a math person asked was, if any quadratic equation can be written in this form, ax squared plus bx plus c is equal to 0, what happens if I do this completing the square process? What if I subtract c from both sides? Right? What if I divide both sides by a? What if I go through all that process? Can I solve for x? The answer is yes. And you know what you end up with? Yes, the quadratic formula. So, does anyone have that memorized? Negative b plus or minus. Oops, sorry. What? Square root of b squared. I don't want to hear any singing.
You guys heard the singing parts too, right? Oh my goodness, it's not just
Okay, so yeah, memorize this as a shortcut to solve any quadratic equation. But know that you're really doing a shortcut of completing the square. Okay, so let's practice applying the quadratic formula. It's hard in its own right because you have to memorize something and then you have to simplify it. And simplifying it's not so straightforward. So let's practice these two examples. Okay, first example 9. Well, it's not in this form yet. So what should I do first? Let's add 10x to both sides and let's add 6 to both sides. One side needs to be 0. The other one needs to be in descending order. Then we need to identify what's A, what's B, what's C. A, B, and C. So now let's go ahead and apply this formula. X is equal to negative what? Okay, negative 10, very good. Plus or minus the square root of 10 squared minus 4 times what times what? 3 and 6. All right, all over 2 times 3. All right, I try to color code it. I guess I color coded it wrong. All right, B is purple and A is green. Okay, there it is. Now we simplify. So in order to simplify, we'll write this as negative 10 plus or minus, what's 10 squared? 100, 4 times 3 times 6, minus 72. And I guess the arithmetic I won't like spend a lot of time on because it's a calculator course. So minus square root of 28. And does 28 have any perfect square factors? Very good, 7 and 4. So we can write this as, do you like to keep it under a single denominator or split up the denominator? I would say splitting it will create less mistakes when you reduce it. But I'm fine with you doing it either way. So if we split the denominator, it would be negative 10 over 6 plus or minus. So square root of 28 we can write as 4 times 7, you said? Which would be negative 5/3 plus or minus 2 root 7 over 6, which gives us x is equal to negative 5/3 plus or minus, and we can reduce the 2 and the 6 to get square root of 7 over 3. Okay, but if we kept it in the same, maybe I'll do this in gray. So we could write it as negative 10 plus or minus square root of 4 times 7 over 6 is equal to negative 10 plus or minus 2 root 7 over 6. You just need to remember to factor out a 2 and cancel it from both the top ones. The most common mistake being, so a lot of people just leave the 2 out in front of the square root. So just be very careful that you're canceling a factor of the numerator. Because when we're canceling, we're dividing. So we're actually doing an in-between step where we're writing it as 2 times negative 10. No, negative 5 plus or minus square root 7 over 6 is 2 times 3. And we're reducing 2 divided by 2. So I'm just pointing that out as a common mistake that happens. Okay, what do we need to do for the next one for quadratic formula? Yeah, 2w squared minus 2w plus 5 is equal to 0. So I added 5 to both sides. Okay, so what's our formula for quadratic? In this case, w equals 2 plus or minus square root of negative 2 squared minus 4 times 2 times 5 all over 2 times 2. So this gives us 2 plus or minus the square root of 4 minus 40. Do you want to split up the denominator? Well, do whatever you're comfortable with. I'll write it as 2 over 4 plus or minus square root of negative 36 over 4, which reduces to 1/2 plus or minus, what's square root of negative 36? 6i over 4, which is 1/2 plus or minus 3/2 I. Okay, any questions about this? So if on the test it says solve this quadratic equation, which method are you going to use? You can use any of them, right? What tends to go fastest? Factoring when it works, but doesn't always work. And then you need to decide what's faster for you, using quadratic formula, completing square. If the test says solve this by completing a square, you don't have an option, right? And that is a skill we're going to use in the future for other things. So it's good to just nail it down now. Okay, have you heard of this term discriminant? It's just referring to what's inside the radical of the quadratic formula. B squared minus 4ac. So nothing new to memorize, right? So when do we have complex numbers? When that is negative, right? Square root of negative is I, right? So if this thing is less than 0, we get complex numbers. What if it's positive? We get real numbers. Square root of positive is positive. And what if it's 0? Plus or minus 0 means we only get one solution. The plus or minus disappears, right? Okay, so what's the discriminant here? 10 squared minus 4 times 3 times 6. Our answer is 100 minus 72, 28. So what does this tell us? Positive 2 real number solutions. Okay, I'm going to skip to these two, but it's the same thing. You're just going to look at the chart. Is it positive, is it negative, or is it 0? Okay, these are more difficult problems that show up on your homework. This one, we would just use the square root property. So I'm going to do this one to the right, example 14. If I'm solving for t, this is a quadratic equation because t is squared. Right? So I'm going to treat m, n, and z as if they're just numbers and use the quadratic formula or completing the square. So what's the first step I need to do here? I need to subtract z from both sides. Let me write that. Minus z to make one side 0. Okay, so what is a equal to? M. What is b equal to? N. And what is c equal to? Close? Yes. C is equal to negative z. Okay, so I use a quadratic formula. What am I solving for? T is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So let me make sure I color code this right. B is n. So I'm going to plug in n in green. Then a is m. I'm going to plug it in blue. And c is negative z. So this is actually better than with numbers. Do you believe me? Why do I say this is better than having numbers? Yeah, I can't really simplify, right? Plus 4mz, and I'm done. All right. Any questions about this? I'm gonna work on this problem so that you have this for your notes. But we are out of time, so you are free to go. No, what's going on?
It's just about the previous assignment. There's one question I have.
Okay, if you follow me upstairs to my office, is that okay?
I guess.
Okay. I will have an office hour right now from 2 to 3. If you want to come upstairs, feel free to join me. Oh, thank you.